Hi everybody, and thank you very much for joining us at the Microsoft Power BI UK user group. My name's Leon Gordon and I'll be your host for this evening in today's user group webinar. We're going to talk about data modeling, and Ed's going to give us a very in-depth overview of data modeling. I know that a lot of our users recently have asked for more information on this subject, and so we're happy to bring this to you. So as always, in terms of our user group, you can ask questions through the Q&A functionality, which I'll open shortly. I will then take those questions and pose them to Ed throughout this session. And so please do feel free to ask questions throughout. It's very much an interactive session, and we want everybody to continue to learn. So without any further ado, I'll just give you some background on Ed. So Ed is a Microsoft Data Platform MVP. And he's also a certified public accountant who decided that data was more interesting than journal entries. And I don't blame you on that one at all, Ed. So most of his data analysis career has involved Microsoft Access as a backend and Excel until about the early 2010s when the Power Query and Power Pivot and what we're blessed with today in Power BI came to fruition. And as I mentioned, in 2020, you were given the Microsoft MVP award for data platform for the Power BI community. So hopefully that's a very good introduction, and I'll pass over to you, Ed.
Great. Thank you very much. So as Leon said, this is meant to be sort of an interactive session as I'm going through the presentation, which I will pull up here in just a second. Feel free to ask questions. As I told Leon, I would rather ask the questions kind of when I'm in that area instead of waiting, 20, 30 minutes and somebody asks me, I have to go back. We can do it either way, but feel free to interrupt. So I'm going to go ahead and start. We will do a demo with Power BI Desktop kind of towards the end of the session. So with that, I'm going to share my screen. So you should be able to see my screen. And I'm going to minimize this down here. So I'm not going to be able to see much. So just audibly interrupt. So this is Data Modeling 101, making the most of Power BI. And this is really important because Power BI is designed to work in a certain way. It's not like Excel. Excel is a big spreadsheet, a wide open area, and you can do pretty much anything you want and get it to work. Power BI does not work that way. If you do things the way it is not expecting, you can still get the answer. It will be slower, less efficient, and maybe your coding is harder. So this is designed to help you. If you understand how Power BI works, you'll be able to do better data models and make your life easier. So this is about me. I'm not going to go through it again, other than to say my Twitter handle is there at the bottom. If you want to follow me, it's a perfectly safe account to follow because I don't do anything except Power BI and maybe some dad jokes, some funny memes, etc. So feel free to link to me there. So the goal here is to understand what is data modeling in Power BI. Why should you consider it? What are the basics of data modeling? We're going to understand what a star schema is. You're going to hear me use that term multiple times if you've never heard of it. Power BI is designed to work with the star schema. We're going to understand what filter propagation is. So you've been taught as you create measures and formulas how filters work. We're going to understand how that works in the model. And then we're going to touch base on date tables and why date tables are important and how you can create them using Power Query to create a fully dynamic date table that will make your life much, much easier. This is your overall Power BI desktop development environment. And we're going to go just a little bit more in detail of each of these 4 screens. But you'll see here in the upper left, you start in Power Query. This is where you get your data. You bring it into the model view. You create your data model. Then you have the data view where you can do a little bit of work. You can look at some data, see how things are going. You can add calculated columns here. We'll talk a little bit more about that in a few minutes. And finally, you get to the report view. The problem with Power BI Desktop is it throws you right into the report view when you load it up. And so people start clicking and dragging and creating visuals. It's a very good way to get started fast. But if you haven't taken the time to set up your data model properly, you will very quickly paint yourself into a corner. And so the goal of this session is understanding the importance of spending time in Power Query in the model view first. It'll make your report writing much, much easier. So let's dig in to each of these four in a little bit more detail. Power Query is where you extract, transform, and load your data. It's called an ETL tool. You might have heard of that before. It has access to over 100 data sources in the product itself. More and more vendors are coming out with what are called custom connectors. And so even if you say, get data from and your vendor's data source is not listed, contact that vendor. They may have a custom connector that you can fairly easily add to Power BI and then get data directly from their data source. It is ideal for shaping data. What is shaping data? This is where you're renaming columns, you're removing columns you don't need. Maybe you're bringing in some tables that you only need some data from, so you're merging that into your main table. And then when you're done, you could close and apply and you load. We'll walk through this in a little bit more detail in a few minutes. Once you've done that, you should have created the perfect model, okay, the semi-perfect model anyway, and it would be a star schema. In the model view in Power BI, this is where you create your filter relationships. We'll go through what that means, but these lines on the screen are not joins. They are filter relationships. We'll understand what that difference is in a little bit. This is where you create your star schemas. Believe it or not, what I have shown on my screen is a perfect star schema. It's actually two star schemas, one for the sales, one for purchases. It's too small to see here. That's fine. We're going to look at this in Power BI Desktop in a little bit. This screen is also where it is ideal to hide fields that you don't need in your report view. You can add synonyms to your Q&A for artificial intelligence, so your users can type in what was my gross revenue for last year, or what was my gross sales for last year. You can add those words in here as synonyms that will make it easier for users to query using whatever language their business uses. Different businesses have different lingos. Then you can go into the data view. There's not a lot you can do in data view. You can view tables and fields. You can filter data for analysis. For example, you can filter and find out how many records you have that were in a certain country or were over $100 or whatever. But understand, when you're in this screen, the filtering is visual only. It is not actually filtering out the data. It's not going to affect your report. It's just a way for you to look at that information and get a little bit of information about what's going on without having to export it to Excel and do similar analysis. Finally, you get to the report view. And the report view is where you add your visuals. And this is the fun part, right? You're adding visuals, you're adding fields, you're setting up how the visuals interact with each other with cross-filtering, creating bookmarks, etc. You control all aspects of user interaction here: buttons, filters, slicers, bookmarks, all the visual interactions. This is also the primary place where you edit measures. So you're creating your measures, dropping them in, and looking at your data. But you'll notice, as I went through the four parts of Power BI Desktop, this is the last place you go. It is not uncommon for me, when I'm building a report, to spend half an hour to several hours in Power Query actually going through my data, deciding how I want this model to work. When I start talking in a few minutes here about dimension tables, fact tables, relationships, you'll understand what I'm talking about and why Power Query is the best place to do that.
Hi, Ed. We got our first
Yes.
question. Hope you
Sure.
don't mind me jumping in.
Yes.
So this question's from Irakli, and they ask, they've been trying to stick to the recommended star schema, so obviously fact tables and with dimensions. They would usually have one-to-many relationships from dimensions to fact tables, but recently they've started to use slowly changing dimensions, which basically means they can't use one-to-many relationships anymore. So the question is, in this scenario, what are the best practices here, and how do they model their data?
Okay, so that is a little bit more of an advanced topic. what I would recommend, it is possible to use many-to-many relationships safely. You can also use a technique called a bridge table. And a bridge table is typically, in my opinion, better overall. Again, the answer is it depends, right? It depends on your data. But there is a concept called the bridge table. I'm going to briefly touch on that later, but that really is a topic for another entire presentation. So just maybe jot down that term bridge table, and that would be a topic for either reading a book that I'm going to recommend later that has an entire topic on that, or looking at some articles on how bridge tables work. So
Fantastic.
hopefully
Thank you, Ed.
helps at least give you some guidance on where to go.
Definitely. Thank you.
Okay. Anything else? Okay.
We do have one more from Christian,
Okay.
so we'll ask this one now as well. So how important is Power Query in data modeling? Would you recommend Power Query versus DAX calculated columns?
Yes, so we're going to really dig into this a little bit later. And in fact, that's what this next slide is on. It is about using the right tool for the job. So when you are shaping your data, in my practice, there are only two places that are acceptable to do it. Either you do it in Power Query, or you do it before Power Query. For example, if you're getting your data from SQL Server, it is perfectly acceptable and oftentimes preferable to shape your data in SQL Server using views. And then you use Power Query to just bring it straight through. There are going to be performance issues, circular dependency issues, etc., if you use DAX using calculated columns. The biggest problem I see with Power BI users, and I was doing this myself early on, is you get in that data view where it shows the tables, and you say, wow, this looks like an Excel spreadsheet. I can add a column. I can start doing formulas. And you just go to town adding 30 or 40 calculated columns. That's going to cause you problems. So we'll dig into that a little bit more. But as this slide is showing you, the best way to shape your data to set it up for correct modeling is Power Query, or like I said before, shaping it in the source system. DAX is designed for analysis. It is not designed for shaping your data. There are certain functions, like if you're trying to get text strings correct, left, mid, and right, those were only added to DAX so they could mimic what was in Excel. Those are not really data analysis functions. And there are functions in Power Query that do it much better, much quicker. And when the data is imported, your data will typically compress better. So Power Query for shaping and correct modeling, DAX for analysis. By the same token, I've known some people that just love Power Query and they're doing percentages and all this analysis in Power Query. That's not what it's for, and it's going to slow it down. You're going to be limited in the analysis you can do. So it's figuring out the right tool for the job. Some things are very clear. You want to delete a column, delete it in Power Query, because you cannot delete it in DAX. You want to do percentages, you absolutely do that in DAX. Other things, you've got to kind of figure out where in the middle you want to do that. Is it Power Query? Is it DAX? So as you learn, you'll kind of get a sense for, okay, Power Query is probably better. DAX is probably better for this other thing. And there have been times where I've done it in one, and after an hour, I'm like, nope, I'm going to do it in the other. And you kind of figure that out as you go. Okay. So right tool for the right job. And Power BI has two tools for this. One for shaping and modeling your data, the other for analysis. Use the right component. That's why it ships with both. So what is data modeling? So I'm not going to read all this text at the top. That's from Wikipedia, but it is a basic concept of what data modeling is. But I am going to read this here in the bold because this is important. A Power BI data model is a collection of tables with filter relationships that enable your business users to easily understand and explore their data to get business insights. So that is the key. You're trying to get your end users to easily see what's going on in the business or whatever it is you're providing data for. Advantages of data modeling. It's going to make the data easier to understand. It's going to make your life as a report author easier because your DAX measures are going to be easier. Towards the end, we're going to go in and look at a data model, and I'm going to do a few calculations incorrectly and show you how the DAX gets more complex to get the same result versus just doing it, the correct way using a star schema, using the correct fields, and your DAX code becomes much, much easier. So you're going to make your life easier if you'll spend a little bit of time early on getting it shaped properly. It also allows you to harmonize different data sources so they have a cohesive structure. In an ideal world, you only have one data source. Everything's in SQL Server, you bring it in, and you're done. That's not the real world. The real world is a lot of your data might be in SQL Server or Oracle or SAP or whatever your company uses, but then your budget is in a spreadsheet. You might be pulling in data from a SharePoint list or some CSV files. Maybe you're exporting some sales data from Amazon, and you're bringing all that data in. Well, they all have different formats. The field names are different. The type of data it is different. Power Query lets you harmonize all those field names, merge and append, combine the data so that maybe you have a lot of internal sales in your ERP system, and then you have some Amazon sales that you're selling through from that system. You bring it all in. When it comes into the data model, it just looks like one table because you spent all that time modeling it properly. You cannot do that in Power BI's DAX model. That has to be done, like I said, either in Power Query or even earlier on in some other ETL tool. So again, we talk about harmonizing different data sources, over 100 systems. These are just a few of the more common ones: Microsoft Access databases, CSV files, Essbase, MySQL, PostgreSQL, etc. These are all places, and Power Query will take all of those, and you combine those and make one common, sales table, one customer table, one item table, whatever your business is. So let's talk about types of models. We've talked a little bit about Star Schema. I told you what it is. When you've been working in data, there's typically 3 models out there. There's a flat, or what is called denormalized model. And if you've ever done pivot tables in Excel, this is what you're used to. It's the old way of doing a pivot table. You have one table, and you have to keep adding more and more columns to it using a VLOOKUP. You have your customer information, then sales information, product information, etc. And you just keep doing more and more VLOOKUPs until your table gets bigger and bigger and bigger. And then you start working on your pivot table. On the other side of the spectrum, you have what is called a Snowflake schema. And I'm going to show you an image of that in just a few minutes. This is what your ERP systems typically are: SQL Server, Oracle, whatever system you're using. And that is because they are designed for add, change, and delete operations. You're adding a customer, you're adding a record, you're deleting a transaction, you're changing a transaction. Snowflake schemas are the best for that. In the middle of that is the Star Schema. And a Star Schema is optimized for query operations. So Power BI, SQL Server Analysis Services, and Power Pivot in Excel are designed for this. A lot of people don't realize this, but when you launch Power BI Desktop, you are actually launching a runtime version of SQL Server Analysis Services on your computer. It's an extremely powerful analytic engine, and it is designed for query models. So this is what you want to use. You're designing your model to fit what the product expects, and then it's going to run very fast. So let's take a look at a flat or denormalized model first so you understand exactly what's going on. Here you can see we just have one big table, and over here we have some product information. Well, next to that you've got the date. Okay, maybe that's okay. But now you have customer information. Okay, well, customer information is not really related to the product information, maybe what the customer bought, but the Maximus UC50 here doesn't really have anything to do with that email. And it certainly doesn't have anything to do with the marketing campaign. And now you have, some units over here, etc. It just gets bigger and bigger. And you've all seen these tables that are just, extremely wide, 50, 100 columns. It's highly inefficient. It's difficult to understand the data, how these things relate to each other. The model has extra copies of dimension fields. It slows down performance, and the table just blows up. So this is a Twitter exchange that happened a couple of weeks ago. Well, it was actually back in February, so now it's a few months ago. And somebody asked, why is the Power BI calculation faster in a star schema, although in theory, a flat table should be faster because there's no joins, there's no filter relationships. And this person responded, Amir Netz, I don't know if you've heard of him, he actually developed what is called the Vertipack Engine. It's what is going on in SQL Server Analysis Services. This is what's doing all these hyperfast calculations when you're running Power BI. He said the official answer is Vertipack works best with narrow tables since it compresses the data better. The cost of joins is smaller than the cost of having a wide table. So we would see how this table that we have on the screen would actually be split into at least 4 tables. You would have a product table, a customer table, a date table, a marketing campaign table, and then your fact table, which is where your sales, cost of goods, that information goes. That will actually perform better in the long run. All right, let's look at the other extreme, a Snowflake schema. So you've probably seen databases that look like this. This is perfectly acceptable because, again, it's optimized for these add, change, and delete operations. However, it's inefficient for a query model, and here's why. Let's say you have this loaded into Power BI Desktop, and you have all these tables in your model, and you want to summarize everything by product category, okay? Here's your sales. This is your fact table. So you have your product key, the order number, you have, quantity, price, the things that happen when the order shipped. You want to group everything by product category. Well, where is product category? It's way down here in this table. So you have to memorize what all these tables are, and you've got to go through 1, 2, 3 different joins to get there to create your model. So not only is the model more complex for you to remember, Power BI has to do 3 table hops to get there. It's going to slow down the model just a little bit. There's a slight performance hit with every single table hit. Well, that really comes into play when you have a bunch of slicers and filters on your report. Every time a user clicks a slicer, the model has to think, I've got to go through 3 tables to get there, redo the data, etc. In Power BI, what we would probably do is we would merge all these into one table. There's your product table. This looks like, some customer information with some geography. You have your date table, you keep that separate. And then this looks like, your territory, maybe you have promotion. So now you only have 3, 4, maybe 5 dimension tables. Makes it much easier to understand, and you have one fact table. Okay, and that's what we're going to look at now, is a true star schema. Okay, now I've got a little footnote down here. If you want to really know what dimensional modeling is, you can Google a person's name, Ralph Kimball. He developed this, I believe, back in the 70s. This is not something Microsoft invented. And Microsoft is not the only one that uses the star schema in their product. SAP has it, Oracle has it. But the Vertipack Engine is probably among the best in the market. The way it was designed, and you have that running on your desktop, it's running in the service, it's extremely efficient. And it is designed to work with the star schema. So here we have across the top our dimension tables. Some people call them dim tables. And down here at the bottom, I have one fact table. The fact table is what's going on in the business. So we have our dates, stock item, supplier key. Then we have, is the order finalized? What were the quantities ordered? More fields down, we might have the price, the shipment date, et cetera, et cetera. Here in our fact tables, we have all the information. So the date table is very important. You always have to have the date, but now you have a lot of rich information around that date table. The day, the name of the day, the week of the day of the week, the day of the year, number of days in the month. My date tables have 50 or 60 columns. The month name, the short month name with just 3 letters, the month of the year, the month in the model. You can, roll the months back and forward, roll the years back and forward just by counting. Go back 2 years, go back 1 year, etc. All that's in here. Things that probably are going to come from your ERP system in some way would be your item or your product table. It has the brand, the package, the color, what's the production lead time, what's the recommended retail price, etc. So a lot of rich information. All of that is kept in the dimension tables. Your fact tables, your purchases here in this example, only have the bare necessity of information as to what happened with that transaction. And then between those, you have the one. I got too many squigglies on my screen. You have the one-to-many relationship. It is a filter relationship. It is not a join, and I'll explain that a little bit more. If you've ever worked with Microsoft Access or you're a SQL developer, you have probably worked with joins. I'm going to go back to my Snowflake schema. These are actual joins, okay? And in a database product like SQL Server, you can have multiple joins per table. Maybe it's not just going from the product key here. You might have it with also the order number and maybe the order type. You can have multiple joins between tables. That's perfectly okay in a normal relational database. You cannot have that in a query model, because the query has to know what your filter is being applied. And I'm going to show you, you may have seen joins before or filter relationships that are dotted, okay? And the reason they're dotted is there's an active filter and an inactive filter. I'm going to show you an example of that. You can create multiple joins between tables, or I'm sorry, relationships, but only one can be active. So it's very important you understand. I'm spending a little bit of time on this for a reason. If you're a database person, these are not joins, they're filter relationships, and there is a subtle difference when you get into building the report.
Ed, now's probably a good time to jump in with a question from Christian. So that they ask, having multiple date columns in a fact table with the need to report on more than one of those dates, what and why should they choose? So option 1, to keep a single calendar table and create measures with use relationship, or option 2, create multiple calendar tables.
Yes, and the answer to that is it depends, and we're actually going to go through that in a few minutes. If you're only doing calculations, I would say it is almost always better to have one date table and then you use the use relationship modifier and calculate. The only time I will create multiple date tables, and that's perfectly acceptable to do, is if you need to be able to slice by multiple dates and it becomes impossible to do with just the way the calculations are set up. So you could create a use relationship on the delivery date, for example, and still have one date table and slice by that delivery date. However, it would become a little bit tedious to slice by the delivery date instead of the invoice date for multiple columns within that. So quantities, etc. So again, it depends. And you may start heading down one path and decide, you know what, I want to try the other path, create a second date table. That's fine. But what you want to avoid is creating a date table for every single field in your fact table. You may wind up with 2 or 3 date tables, and then everything else is use relationships. So again, there's no right or wrong answer. It's an it depends. But I start with one date table and use relationship. But we're actually going to walk through a demo of how that works in a minute for everybody else that may not understand what we're talking about when we say use relationships. So that's a great question. Anything
Fantastic.
else?
There is, but as we're going to walk through that demonstration in a moment, I think it's probably best to hold them till after the demo.
Perfect. Okay. All right. So we've talked about dim tables and fact tables. So what are dim tables? Short for dimension. These are your dimensions. Dim tables are wide and short. What does that mean? Wide means they have many descriptive fields. Your item table may have 50 or 100 fields describing that item. It'll have certainly the name, maybe the product category, the subcategory. It might have material type. It might have the duty rate. It might have the duty code. Many, many fields. But it's going to be relatively short. Short meaning it's not going to have a lot of records, okay? You may only have 100 products in your company. You may have 500 products. You may have 500,000 products if you're Amazon. That's still relatively short compared to how the fact table would be. If you have 500,000 products in your Amazon, you're pumping out a few 100 million records a day in your fact table. So even that would be a relatively short table. And one key fact about a dimension table is it always has one field that has a unique value. So in an item table, it might be your product number. In the date table, it's going to be the date itself. In the customer table, it would be the customer number. There's always one field, at least, with a unique value, and it is the one of the one-to-many relationship. Okay. On the other side of the table, we have the fact table. Fact tables are typically narrow, so they don't have a lot of fields. You don't have a lot of descriptors. There is nothing in that fact table about the item except the item number itself. You don't need the description. You don't need the category. You don't need any of that information. You only need the item number itself. Same thing with customer number, etc. But it is very tall, potentially millions or hundreds of millions of records because you're selling every day. And rarely will any field be unique. It is possible that there will be no unique fields in that at all because things are constantly repeating. You're selling the same item to different people, but to those different people, they're buying from you multiple times on the same day. Multiple people are buying. So there's a lot of repetition there. And that's how fact tables are set up. This is what's important about shaping data in Power Query. A lot of ERP systems will add these duplicative fields to the fact table. So you have your invoice data, and it might have the product description, the product category, etc. That's fine. That's how ERP systems work. When you bring that into Power Query, before you load that into your data, you're going to want to get rid of those redundant fields. You don't need them in your fact table. You're going to use your dimension table to describe your data. You only want your fact tables to analyze the data, okay? So back again to a star schema, we have your fact table here. It's surrounded by the dimensions. So we have here again, item, date, and vendors. And you can see we have the one side and the many side. And you'll notice here, and I'm going to talk a little bit more about that as we go on, you'll notice here that I have hidden these fields because they're related. The date field here is what is related to this date field here. I never ever want to use that date field in my report. I always want to use the key field from the dimension table or any of the related fields from the dimension table in my report. So to protect me from myself, I hide that date field that's in the fact table. The same thing here. I'm going to hide the stock item key and I'm going to hide the supplier key. You never want to use those. You're going to get into trouble. And I'm going to show you how that's going to cause problems when we do the dimension, when we do the demonstration. Okay. Filter direction. This is important. When you're looking at your model view, it should have the one-to-many descriptor, and there is a filter relationship. It shows you how the filter runs. The sales table is not filtering the item table. The item table is filtering the sales table. It shows how the direction goes. And you'll notice that when I set up a star schema, my star schemas do not look like star schemas, meaning the fact table in the middle and your dimension tables around it. My star schemas look like this. I always put my dimensions across the top and my fact tables at the bottom. And here's why. The filters run downhill. So I have this mental image of my fact tables are at the bottom and they don't filter anything. My dimension tables across the top and the filters run downhill. A lot of people call that the Rob Colley method. He wrote one of the first Power BI, Power Pivot books back around 2012, I believe. He developed this method. It has nothing to do with performance. It has to do with the human piece, understanding how everything works. So you'll see, if you've ever read any of Matt Allington's books or his blogs, he'll say, arrange your data in the Rob Colley method. It's just a trick to help you understand how your data looks and how it works. Okay? So let's look at this from a database person. You have a Snowflake schema. You have your customer table that comes out of your ERP system. Over here, we have a buying group. If we looked over here, further out off screen would be your fact table. So we have a Snowflake schema. We have the buying group here, but to get to the purchasing power field, we would have to go through a join or a filter relationship to the buying group. This is what you want to fix in Power Query. In Power Query, you would turn this into a single customer table. We have merged the purchasing power into the customer table. So now we know what the purchasing power is in one table. The buying group field, there's only one of them now. There's not one in the customer table, one in the purchasing power table. But some of you are thinking, well, wait a minute. We only had 2 or 3 fields in the purchasing power field. Now we have, 6 or 7 here and 12 here, and depending on your table, could be thousands and tens of thousands. That massive repetition is okay because the Vertipack engine in Power BI doesn't store the table like this. It stores it in a columnar format, so it actually breaks the table up into, it would be 5 different kind of mini tables that are grouped together. So you look at them as tables, and then it starts compressing the data. And it would only store, without getting too much into details, it would only store standard one time. And it would say it applies to rows 1 through 5, and then it would only store discount one time, and it applies to these rows. That has 2 benefits. One, your model is smaller. A lot of Power BI models, if set up properly, can compress 10 to 1. So you might have a very large model that's a gig of data. It might only be 100 meg when it's loaded to the service. The other reason is these tables remain compressed when Power BI is working. It's not unzipping them and then doing the work. It leaves them compressed, and it can read the memory faster. Even as fast as computer chips are, it's faster for a computer chip to read 100 meg of information and do a calculation on what's compressed and what's not than it is to read a gig of data. So it makes the product work faster. So this is completely contrary, though, to how databases work. Databases need them split out for the add, change, delete operation, not so Power BI. All right, so let's step back for a second and understand how that process would look in real time. Getting your data. You launch Power BI, you're right there at the report screen, and it says, get data. You click on get data, and there's a big yellow button. I'm going to show it here on the next screen. It says load. That is a bad idea. It's in yellow. Microsoft is like, click it. You can go ahead and start clicking, dragging, and dropping. You're going to get yourself in a world of hurt if you click that load button. Instead, you want to select transform data. The reason is it's not going to be a star schema by default. So that right there is a problem. It's going to have unintelligible field and table names because it's coming from your ERP system. Your ERP system does not have nice field names. It has computer geek speak. Fields in SQL Server databases, Oracle databases, they cannot have spaces. They'll have underscores or they'll ram everything together. That's not good. You always want to rename your tables and your fields in clear English names or the name or the language that your audience is in, including spaces with proper capitalization. The reason is the artificial intelligence, if you start using those AI fields, people will type in, what were my sales for last year? And if year is like YR or sales would be like SLS, that artificial intelligence is not going to work. So even if your data is in very good shape, spend time in Power Query renaming things. Finally, it's probably going to have way more data than you need. Remember, I told you your fact table coming from your server would be sales, and it might have your item number, and it might also have the description and the category and a few other descriptors in the fact table. Get rid of all that. You only need the item number. You're going to keep everything else in your dimension tables. So get rid of those columns you don't need. And I will say this as a development tip. Be overly aggressive in Power Query. Get rid of more than what you think you'll need. It is easy to go back and undelete fields and bring them through. What I have seen happen too many times is you get a fact table and dimension tables. There are fields in your dimension tables you don't need. I work with a client that has an item table, and it has things like material types. You know, what's the primary material type and the secondary and the tertiary type? You don't need that information for a sales report, but people bring all that in, and then they're like, I'll go back and delete it later. No, you won't. It's just in your model, and it's going to slow it down. What's worse is you think, okay, I'll go back and delete it later, and you start deleting a couple of fields, and then you delete a field that you needed to use, and it wrecks about 10 measures and 14 visuals. Now you spend time fixing all that, and you're like, I'm not deleting anymore. I'm going to leave all this garbage in. I don't care. So when you're in Power Query, narrow it down to what you think you need. If you need a field that you deleted, you can go back and undelete that. You can bring that back through, and your model is going to run much, much better. It's going to make your report development easier. When you go to a table, it only has 20 fields you need, not 200 that your database needs for whatever your business operations are. Okay. The last thing I do is when I bring data in Power Query, you can disable the load on your tables. I will show you what that means in a few minutes. I always disable load. Then when I finish working on a table, I'll enable load, and I will know I'm done with that. It's kind of my checklist on what's been done, what hasn't been done. So this is the consequence of clicking that load button here that I have said is a bad idea. I've gone through here and selected a bunch of tables, and if you hit load, this over here is what you get in Power BI Desktop. That is a complete and utter mess. There is no way this is a Star Schema. You have two different sales tables. Can you imagine the DAX you're going to have to write to get total sales to combine two different tables? And look at all these table names. You don't need the word data modeling. Look at this field, country region. That's not a name. It's either country or region or country space region, or maybe your business has a different descriptor. Look at these fields, sales 2013, sales 2014. You don't want your sales in multiple columns. You want it in one column, and you want a date saying when it is. That's how you write reports. Otherwise, you're going to have to add a bunch of columns together. And then next year, you got a new column for 2022 sales. You got to go and fix all your DAX. Do it right in Power Query, then load it. Okay. I want to show you this to show you how I bring data in. If I go back here, I might need data from all of these tables, but I do not need all of these tables in my data model. So the point of these next two slides is to show you what I have done in Power Query. And I think I can zoom in here somehow. Here we go. Yeah. So I have brought in about 20 tables. This is a general ledger database. But you'll notice under a lot of these, it says load disabled. That is because I used information in all these tables to get down here to this final table at the bottom called the detailed trial balance. When all is said and done, I have only loaded 3 tables in. Over here is the chart of accounts. I have my famous date table that you always have to have. But if you look at all these other tables, this one, it's too small for you to read, but it's a trial balance from 2014 that we had to bring in. I have a period zero data to get beginning balances for retained earnings. I have some detailed transactions coming in from these other tables. I use all that information, but all the data flows through ultimately to my final trial balance. That's all I need. So in these 20 tables, I needed data from all of them. I only brought 3 into the data model: the chart of accounts, the dates, and the detailed trial balance. And that is a very simplistic star schema. Instead of bringing all this in, and I can't imagine how you would do all that in DAX and try to get that to work, and it would just be horribly slow and horribly complex. So any questions about that or anything else I've said before I move on?
Yeah, definitely. I think it's something that you've answered already, Ed, but I'll pose it to you anyway. So Nandini asks, can we merge tables to reduce Snowflake data model towards the star schema?
Yes, and that is exactly what Power Query is designed for. So in Power Query, you can have 2 tables, merge them into one table, and you only bring in the final table. So your DAX model only has one table in it as a result of that merge. If you tried to do this in DAX, you would have 3 tables. You would have your original table, your second original table, and then you could use, natural inner join or whatever DAX you're going to use, summarize tables, summarize columns, whatever, and you now have 3 tables in your DAX model. So now it's overly complex and it's going to be slower to run. So absolutely. And Power Query, you can combine tables in 2 ways. One is a merge. Think of a merge as a VLOOKUP. It adds data to the right. So maybe you have, maybe your ERP system has 2 item tables, or let's say it has an item table and a category table. You would merge your category into your item table using the category field, but then your category table has a bunch of extra columns to it that give more description to what region it's sold in, et cetera. You bring those in to the right. So it's kind of like a VLOOKUP, right? But you do multiple fields at once. Or you can do what is called an append. An append would be, let's say you have sales from your ERP system and you have sales from Amazon. What you would do is you would shape those tables to where they looked somewhat similar, and then you would add it to the bottom. So you have all of your sales from your ERP system, and then finally all of your sales from Amazon, and it is one big long fact table. So both of those can be done easily in Power Query. Neither can be done easily in DAX, and some of them cannot be done at all. And in DAX, again, you're going to wind up with everything, whether you combined it or not. In Power Query, you simply say, don't load my original item table, don't load that Amazon table, just load the end result, disable everything else. It uses all that, but only your final result is there. Nice clean star schema. And that's what I have here on the screen. 20 tables coming in, 3 tables going out.
Fantastic answer, Ed. And one last question, which might be
Sure.
slightly off topic, but for your screen interaction software, are you using Whiteboard?
No. So this is, I'm cheating here. This is actually PowerPoint, and PowerPoint has inking capabilities built in. I'm using a Microsoft pen. I don't know if you can see it on the screen. But I write on it, and then you just hit the letter E and it erases everything. So it makes it handy to work with. I've got another app that I'll use here in a minute when we're actually going through, and I forget what it's called. It's some pen application that lets me write on anything. I'll get the name of it though before we're over.
Okay? Perfect. Really appreciate it. Thank you.
Okay. So development tips. So these are things that will help you make your data modeling experience a little bit better. And we're gonna start here to switch to Power BI Desktop as we go through this. So the first thing I always do is disable automatic date time intelligence. Just you do it. This one is 100%. Always do this. If you have dates in your data, always create a date table. Do not use auto date time intelligence. End of story. We'll talk about that in just a second. This next one, disable type detection on unstructured data sources. I would say that's 80%. And I'll show you why that causes problems if you leave it alone. You always want to display the Power Query formula bar. Again, 100%. Always want to do that, and I'll show you why. You can do that globally in Power BI Desktop. You go into File, Options, Global Changes. I'll show you where these settings are. Per file changes, disable automatic relationships. Unfortunately, you cannot do that globally. I always do this because I have been bitten by more than once by Power BI creating a relationship where one did not belong, and my measures don't work right because the filter relationship was improper. I would rather, I don't care if I have 10 tables and I got to drag 50 things around. I would rather do it myself and know exactly what's done than have Power BI do it for me. But I would say this one's 50%. Okay. But it forces me to go through and look at my data and make sure I know what I'm doing. Okay. Impact of auto date time intelligence. If you leave it enabled, and if you install Power BI Desktop, it is enabled by default. You disable it in options. But if you don't, it will add a date table for every single date column in your model, whether you're going to analyze it or not. Now, I was working with a client 2 days ago. They had some data coming in from one of their product tables that had expiration dates. Most ERP systems do not have the provision to say this product doesn't expire. Instead, they say create a fake date in the future to expire, and they will use the date. Sometimes it's December 31st of 2099, 2999. This particular system was using 9999. Well, guess what? Between today and December 31st of 9999 is 2.9 million days. That is a 40 meg date table for no good reason. Nobody's going to be doing date time intelligence on that. So always disable date time intelligence. Additionally, you do not need a date table as a rule for birthdays unless you're doing HR related information. For the most part, if you got birthdays or the date the customer first bought from you, etc., usually you're not doing date time intelligence on that. You're doing it on date of sale, date of production, clock in rates, whatever from your employees, etc. So always disable it. I do have, you can get this QR code. We'll make sure this link is shared. I'll make sure that Leon has everything at the end of this presentation. But I have a date table that you can get to on the internet. You can just go to bit.ly and it's date table by Ed. It is a full, I don't know, it's like 70 lines of M code. Full instructions on how to copy and paste that in. It'll give you a nice rich date table and you can modify it from there just using the Power Query interface. But it's a great way to get started, and included in that link are full instructions on how to make it dynamic. So you don't create a date table 10 years into the future just in case. This date table is actually capable of looking at your sales table, for example, and saying, oh, we now have sales in 2022, and it will automatically expand and include all the dates in 2022. So Power Query is a great way to do it. The other best way to do date tables, get it from your ERP system. A lot of companies have a date table on their SQL Server or their Oracle server. Use that. Don't use Excel. And definitely, and I'm at the risk of offending, the Italians, everybody knows who I'm talking about. I love those guys. They do a lot of DAX. They have a lot of date tables in DAX. It's not the best place for it. It really belongs in Power Query. And that's not to take anything away from what they're doing. They focus on DAX, and because they know their users are in DAX, that's what they do. They don't do any training in Power Query. But if you read the fine print, read their books, they will say, just do it in M. It works just fine. One of the reasons to do it in DAX, and there are some reasons, if you don't have access to the underlying data, that is becoming less of an issue with the new composite model features. You can get a live data set from one Power BI data set and still create your own date table in Power Query and have a composite model. You could not do that a year ago. So it's becoming less and less of a reason to do it. But again, do what's right for you, but I try to do it either in Power Query or from my source system in some way. Okay. Impact of automatic data type detection. So let's flip over to I don't want to keep my things. Let's flip over to Power BI Desktop and show you what I'm talking about there. So if we are doing, then you can see my Power BI Desktop now, correct?
Yes, we can indeed.
Okay, perfect. I want to make sure I had shared my screen. I'm gonna flip over here into Power Query. So I'm going to go to the location table as an example. So an unstructured data source, and let me show you where this is. So if I go to File, Options, you can get also here from the Power BI desktop side. It's the exact same option screen right here on data load. Let me see if I can activate my other pen. It is not working right now. Of course it's not. I tested it before the call. That's okay. Right here it says never detect column types for unstructured source. An unstructured source would be Excel, CSV file, etc. Here's the problem with allowing it to do this. And what this does is when you bring data in, sometimes you will see an automatic promoted headers and change type. That can cause problems down the road if your data changes. Because I'm going to go back. Let me just make a copy of this table because I'm going to kind of trash it here. So duplicate. Okay. So if I get rid of this, delete until the end, show you what this would do. What automatic data type detection is, I'm going to select all these columns and say detect data type. Now you'll see it's created this changed type field for me automatically. And that's something that it would do for Excel. That might be good, it might not be good. First of all, it might not be the right thing. It only guesses on the first 100 or 200 rows, so it might guess incorrectly. The other reason is maybe you have a column here that you're not really using, this latest recorded population. And you mentioned to your coworker, well, I don't really care about that field. I'm not using it anyway. So your coworker goes, oh, great. I'll just remove that because that's kind of a pain to add to it. So they remove the latest recorded population from the data set. You're no longer importing it. Well, that automatic date or that automatic change type has now broken and your scheduled refresh is going to fail. Why? Because it set a data type for the latest recorded population. It's no longer there. So this is why, again, I prefer not to have the product do a bunch of steps for me. It's going to make your development experience better, and it's going to make reports run longer in the service before you get the dreaded something happened in the data set, something changed, and it often happens to be these automatic steps that it does for you. So I'm going to get rid of that because I don't need it anymore. While I am here, I am also going to show you the Power Query formula bar. I believe this is now turned on by default on new installations. It is not for older installations. They got enough complaints about this. They finally fixed this. I think it was 3 or 4 months ago. So if you have an older version or an older computer, when you upgrade, it will not change this for you. It's only working on new computers, new installations. Turn on the formula bar in Power Query, and here's why. I don't care if you never write any M code. That's what Power Query uses. It's called M code, the letter M. I don't care if you never use it automatically. You need to know what it's doing. And I'm going to go here to region, and I want to say, right now I only have 2 fields, Americas and NA. And I know that in my business, NA means it hasn't been properly set up. I don't want it in my data. I want to get rid of it. I'm going to uncheck NA and hit OK. Now, what did I do? Did I tell Power Query, don't use NA, or did I tell it, keep Americas? There's no way to know without the formula bar. So I'm going to go back and look at the formula bar and look here on the screen. And you'll see Power Query did not do what I wanted. It didn't do the wrong thing. It just didn't do what I needed it to do. And here's why this matters. Power Query said, keep Americas. Well, what happens if my next data set includes Europe, or includes Africa, or includes Asia? I would want that. This particular filter says only keep Americas, and that's all going to be excluded. So in this case, I would go up here and simply modify the formula that Power Query used. And now it will remove NAs, but it will keep new things as they come in. So it's very important you keep that formula bar visible, just so you can kind of see what the product is doing. Doesn't mean you ever have to go in there and do anything more complex than what I did, but it doesn't always do what you think it's doing, depending on filters, removing columns, etc. So always turn that on. Again, new installs, you've got it. But if you've got an older computer, maybe older than 6 months, it might not be on by default. Go turn it on. And that's right here in Power Query. Just go to the view, and there's a formula bar checkbox. Very simple to do. Okay, let me go back. I'm going to close this. And go back here. So, impact of automatic data type detection is it can cause refreshes to fail if things have changed. And I showed you how that happened. And it only samples the first 200 rows, and it can often guess wrong. So you get bad filter relationships or outright errors in refresh. How does that happen? The most common example I've seen is with product numbers. A lot of companies start with numerical data, so it just, 1 through whatever, but then they start running out of numbers, or they want to have sub numbers, so they start using letters. So 10,000 rows in, you've got letters. If it automatically picked numbers based on the first 200 rows, once it gets to row 10,000, and now you have item number 1, 2, 3, 4, 5B, it's going to break. So your numbers are really strings. Set it as a string by doing it yourself. Don't let the computer decide what to do. Okay, data modeling do's and don'ts, and then we're going to really flip over into Power BI Desktop. These are just some tips, and you'll have a copy of this, so you don't have to write these down, but just rapid fire. Stick to one-to-many relationships where possible. Avoid bi-directional, avoid many-to-many. There are reasons to use them. You need to be a pretty advanced DAX user. I don't even use them except for very special cases. I try to stick with one-to-many. In the model view, and I showed you this earlier, hide the fields on the many side of relationship. So if you're in your date table and you're relating to the invoice date of the fact table, hide that invoice date after you've created that relationship so you don't accidentally use it in your report. For all of your measures, anything you want to analyze, sales, purchases, quantities, whatever, create a measure for every one of them and then hide that field in your table. And I'll show you why in a few minutes. You hide them once you've created the measures or link to them in your dimension table. In a really ideal Star schema, your fact table will have nothing but measures visible when you're done. That doesn't always happen. In fact, I would say it rarely happens. Sometimes there's fields in there you need, but usually anything you're analyzing, create an explicit measure for it. Even if it's a very simple sum of sales, bracket sales for the sales field, create that explicit measure. You can create a measure table or folders for organizing your measures. You can do this in the model view. And finally, always format your DAX measures. It drives me up the wall to look at a DAX measure that looks like those ridiculous run-on Excel things that you can't figure out where the parentheses are, and heaven forbid there's 17 nested if statements. Format your DAX measures with proper indentation, line breaks, etc. And you don't have to do it automatically. You can use daxformatter.com to do it, or if you're a little more advanced, you can script it in Tabular Editor. It'll go through and format everything for you automatically. And as the people that wrote DAX Formatter, it's Marco and Alberto from SQL BI, they will tell you, if it's not formatted, it's not DAX. It's just a mess. So always format it. It'll help you. It'll help your future self when you have to go in and edit it. Don't use calculated columns as a rule, okay? Not never, but as a rule. use measures. If you need to create a custom column in Power Query, that's fine. Or in your data source, that's fine. Calculated columns do not compress as well. They take up memory when the data refreshes, and it's very easy to get into circular relationship issues. There's a URL here, kind of a tongue-in-cheek name I gave it, Calculated Columns Are Evil. It's an article by Matt Allington. He will go into reasons, this article is like 5 or 6 years old, on why you should not do calculated columns in Power BI. And unfortunately, Excel users are particularly attracted to calculated columns because they go to that data view, looks like a big spreadsheet, boom, they just start using it. So avoid that if possible. Again, it's not never, there are times to use it, but always start somewhere else before you actually go in and do the calculated column. Second, don't use implicit measures, okay? That's where you just drag the sales field into the visual. Here's the reason. One, you cannot modify that measure at all. It's an implicit measure created by the model. There's nothing you can do about it. You can change it from sum to count or average, but you can't add, one of the examples I use is in the US, we have sales tax. Every time you buy something, there's sales tax. Well, in a fact table, sales and sales tax might be in 2 different fields. If you create a measure that has your sales plus sales tax, you can create your sales field, your sales measure, put it in the visual, and you're good. If you had just dragged that in though from your sales table, you drag the sales field in, you create a bunch of visuals, you show your boss, and your boss goes, "Does that have sales tax included?" Well, no, I didn't include that. I forgot. You can't modify that measure to include sales tax. You have to create the measure and then redo all your fields. And heaven help you if you have a bunch of conditional formatting that does a bunch of heat maps and whatever, because all that gets destroyed when you drag in a new field. So create what's called an explicit measure. You do it yourself. The second reason is, and this is temporary, you cannot use implicit measures in Excel when you're using the Power BI dataset or Analyze in Excel feature. Today, that is the rule. They are going to fix that, and it will be possible, but it is still best practice. Always use explicit measures. Don't overuse direct query. Direct query has a reason to be used, but most of my reports are import. Most direct query models are incorrectly used with comments and discussions I've had with many DAX and SQL Server Analysis Services experts. When you use direct query, you are bypassing the Vertipack engine. You're not getting any of that optimization. A lot of things don't work. Time intelligence doesn't work. You cannot do same period last year. You cannot do a number of lookups. They simply do not work in the direct query mode. And the best explanation I had for this is, would you rather your data be cached or uncached? Well, obviously cached, because cached is much faster. And that's what the import mode does. It caches the data, the Vertipack engine uses it. So again, it's not never, but be careful about using direct query. Don't do it thinking everybody has to have everything right up to the minute. Chances are they're only looking at that report 3 or 4 times a week anyway, so it doesn't matter if it's 30 minutes old or 3 seconds old. Don't enable bi-directional filtering. We're going to go over that in just a minute. Also, this is a little unusual here. Don't use one-to-one relationships. If you go into a data model and you see a one-to-one relationship, go back into Power Query and merge those tables. You really have 2 tables, or I'm sorry, 1 table that's just split in 2. Make it 1 table. There's no reason for a one-to-one relationship in Power BI. Don't relate fact tables to each other, okay? This is important. There is an exception for a header detail we'll talk about in a few minutes, but as a rule, relate your fact tables through the dimension tables, and that's what we're going to show in a few minutes. Don't relate dimension tables to each other. That's using a Snowflake schema, and then we've already said this, don't use many or most of your fields from the fact table individual. Use measures or use dimensions from your dimension table. Okay, a little bit on calculated columns. Again, they require more memory. You can easily get into circular dependency issues. They don't compress nearly as well. And for most scenarios, you can replace it with a calculated or a computed column in Power Query or your data source, SQL Server, whatever. Again, it's not 100%, it's most of the time. Start there, use calculated columns as a last resort, or you know for a fact that's where it should be done, okay? So again, it's not never, but it's rarely ever. Okay, just some summary tips. An inefficient model will slow down the report even with small data volumes. If it's quickly and carelessly designed, your DAX code is going to become a complete nightmare. Spend time in Power Query. There are reports I've written that 70% of my development time was in Power Query, not the report itself. It makes the model as small as possible. Only bring in the table and columns that you need. It's going to refresh better. It's ultimately going to cost your company less money, especially if they're on premium capacity. The more memory you're using, the more data you have, the more likely your company has to buy a P2 or a P3 capacity or extra P1 nodes. It actually can cost your company money by just bringing in a bunch of data. And I've seen companies that had to upgrade from a P1 to a P2, not because their reports actually required it, because their really pathetic models required that be done. So again, it's just bring in what you need, make it as small as possible, and then build your relationships purposefully and thoughtfully. Don't allow the app to auto-create them, okay? Briefly, special considerations. Not everything can be an ideal star schema. If you have what are called header and detail tables, so think about a company that has sales, you have invoices, you have an invoice header and an invoice detail. The header might have information like the invoice number, the customer number, the shipping cost, and the shipment date. The detail might also have the invoice number so it can be related to it, but now it has a lot of repeated rows. The invoice number might be on there 5 times because the customer bought 5 products. What happens here is the header table becomes a dual role. It's a fact table against maybe your date table and your item table, but it's the dimension table for the detail table. So you kind of have this little pigtail hanging off of your detail table. Not an ideal, but it does work, and Power BI can handle that just fine. So that is one reason why you might not have a perfect star schema. We talked a little bit about bridge tables. It's an efficient alternative to many, many relationships. It's not the end all be all. There are times for many to many, but I try to start with the bridge table first. We've talked a little bit about composite models. You may have disconnected tables. The what if parameters are disconnected tables if you do those in Power BI. So there's reasons to have a disconnected table that's only used for a slicer, and then your DAX will take care of the rest. You may also have different granularities where it's not easy to join properly like you normally would. For example, your budgets are often at the monthly level, but your sales details at the daily level. So you might have a little bit more complex DAX, a disconnected budget table because of a different granularity. You can get there. It just makes your work a little bit more difficult to do. But again, that all fits within the broad star schema. It's just not an ideal. It's like I call it a modified star schema. Okay. Finally, and this is just, I don't get any money from these. These are just recommendations. If you really want to dig deep about data modeling, including all of those exceptions, this is the book. This is nothing but data modeling. You're not going to learn any DAX or any Power Query. If you want to learn DAX, this is the best book, in my opinion, to start with, Supercharging Power BI. On a scale of 1 to 10, this will take you from a 1 to maybe a 5 or a 6 in complexity. And that's where you want to start. You do not want to start with the definitive guide to DAX. I love that book. I have it. It's dog-eared. I got notes all over it. But if you start with that book, you will quit using Power BI in 2 weeks because it starts at an advanced level. So start with this book. Finally, if you really want to get into Power Query, this is the book to get, in my opinion. It'll, on a scale of 1 to 10, it'll take you from a 1 to a 10. It'll start basic and take you all the way to the advanced. So a lot of people I know get this, read the first half, and they're like, that's good. That's all I need to know. And that's perfect. Okay. So any questions before I dig into really the data model itself and go over what some of these issues are?
No problem at all. Just one question. And do you prefer MDate tables over DAX from Belinda?
Yes, I do. Because again, If you do it in Power Query, first of all, you have a lot more capabilities of what you can do. There's a lot of date functions in Power Query that do not exist in DAX. So your DAX becomes much, much longer. They compress much better. And again, you can make those tables a little more automatic. You can make DAX tables automatic, but I prefer my date tables always come from either Power Query or earlier on. I'm working with a client right now where we're using a DAX table from their Oracle database, and that's fine. I just bring it in straight and do it. I try not to do it in DAX.
Perfect, thank you.
Okay. All right. So here I have a very simple sales purchases model. I'm going to show you my model, and believe it or not, this is a perfect star schema. It is actually 2 star schemas. I have my purchases table here and my sales table, and they're all related in some way to these dimension tables. And to show you how that works, actually, I meant to delete these. Let me delete these so I can recreate them. Okay, so to show you that these are a perfect star schema, I'm going to drag in the purchases table as an example. Then I'm going to right click and say bring in all the related tables. And you will see that is what is actually going on for purchases. 3 tables: date, items, and vendors, and my purchases. If I had done it with sales, it would have also brought in customers and one of maybe the location table or something like that. So you can see that I have, in the complete model, that's everything. This is a perfect star schema. And again, I like to put my dimension tables at the top, fact tables at the bottom. Okay. Now, let's actually look at what happens when you build data incorrectly. Okay. So we do have a perfect star schema, but we're going to kind of ignore it here for a few minutes. I want to analyze sales versus purchases. So here I have my, actually, I think I have the wrong date in here because I was playing around with it. Let me put in my sales invoice date key. And my sales data. So this works. I have my invoice date and I have my sales, and I know that everything works fine. I want to compare on a daily basis my sales to purchases. So I have a very simple purchases measure that's simply taking the ordered outer quantities times my unit price, and I'm going to drag it in here. And I get 181 million every single day. That is not right. And anytime you drag in a field or a measure into a visual and you get the same thing all the time, you have a filtering problem. And that's what we have here. So let's look at our model and figure out what's going on. So here I have my purchases and my sales table and my date table. Sales and purchases are not related to each other. They're related through the date table. Okay. But here's the problem. I used my invoice date in the visual. The invoice date is not filtering the date table. It doesn't go that way. The filter is running downhill. So there's no filter on the date table. Therefore, there is no filter on the purchases table. Okay. There's several ways to fix it. And we're going to fix it wrong several different times. The first way, and unfortunately the easiest way, is, I will just go here and turn on bi-directional filtering. Horrible, horrible idea. Again, it's not never, but it's rarely, and it's certainly not in this case. However, it does fix the visual because now the invoice date is flowing up to the date table and then flowing down to the purchases table, and my data is properly filtered. That is complete and utter overkill, though, and that will cause problems in your model later on. If you've ever done a lot of bi-directional filters, you'll know you get these ambiguity errors and relationships start getting deactivated, and you start getting weird results. So we're going to turn that off. We don't want that. Okay. Now, what I can do is I could turn on bidirectional cross filtering in the measure itself. So let's look at that. You can do this on a per measure basis, and this is greatly preferred to doing it in the model itself. So let me make this a little bit bigger. So I'm going to call this purchases bidirectional. Okay, and it is calculate. I want to use my purchases measure, and I want to use the cross filter modifier. And I want to take my sales invoice date key and my date, and I want to turn on both. So it's going to be bidirectional. Okay, so that's thinking. I'm going to make that currency with no places. Close this. Now I can drag this into the table. And you will see that that is now working correctly. But again, it's a little bit of overkill. Look at this measure, which is simply calculating what my purchases are. It's a sum X of my purchases, my quantities times the unit price from the table. That's a fairly simple measure. To do the bidirectional, I have to incorporate this measure into yet another measure that uses calculate and cross filter. It just makes the model more complex and is completely unnecessary for this particular case. So I'm going to get rid of that. I don't want it. I'm going to close this. Here's how you fix it. If I had done this model correctly, I would have hidden the invoice date when I created the relationship to it. And then I wouldn't have accidentally put it in my report to begin with. So I'm going to go here. I'm going to get rid of the invoice date. And I'm going to go to my date table and bring in the date table as I should have at the beginning. And now it works because the date table is filtering both sales and purchases at the same time. Any questions about that?
That's a fantastic trick there, Ed, and thank you very much for walking us through that. What we'll have to do in terms of time, if it's okay, is I think that what we'd like to do is have you back in the future. Because we're touching on some more advanced concepts now, I think that we should have a data modeling, maybe 101 and data modeling 202.
Sure.
So we do have some questions.
Okay, yeah.
Because we've run over a little bit.
Oh, sorry,
I
I apologize. I thought the time was a bit longer.
No,
Okay.
it's no problem at all. We're having lots of fun.
Okay.
We have a question from Nandini, and they ask, will merging the tables slow down the model? Quite a broad question.
Yeah, so in Power Query, no, it will not. It might slow down the refresh depending on what the merge is doing, but Power Query is very fast at doing merges and can merge millions of records on the refresh fairly quickly. And in fact, if you're merging tables in SQL Server, it will actually send the merge command back to the SQL Server. The SQL Server will do it super fast and send it through. So it will not slow down the model at all because once it's loaded, that merge is done. So very fast.
Fantastic, thank you. And in your experience, Ed, how much have you seen of people try? So in the example you just demonstrated, we're obviously trying to overcome a modeling issue with DAX. And how often do you see developers, seasoned and amateur, get themselves in a bit of a bind?
Amateur all the time because I used to do it myself. I think in terms of Excel, I just had calculated columns. Or I was thinking in terms of like a Snowflake schema. So it's a very easy thing to get into as a beginner. I don't see seasoned developers get into this because they learn the hard way. They learn that this report that took 10 hours and the DAX is ridiculously complex could have been done in a much easier way. So it's just something you learn, and that's the whole point of this presentation, is to help you get over some of that self-learning, learn from my mistakes.
Yeah, I totally appreciate that. And we have an anonymous question. Again, I believe you have touched on this briefly before, but how do I create a date key between a calendar table and my fact table with dates?
Well, so your date table has the date key in it. If I look at my date table here, it has all of my dates from typically my date tables start with the first day of the first year of my model and go through the last day of the last year of the model. So it doesn't matter that today is only, what is today, July 15th. My date table for a calendar year company would still go through December 31st of this year. I just consider that good practice. That's not a hard and fast rule. But then that will always encompass all the dates in your fact table for the relevant data.
Perfect. Thank you.
I hope that answers it.
It does indeed. And as I mentioned, Ed, from my perspective, I really think that it would be beneficial to have another session with you and to look at some more of the advanced data modeling questions. We started there at the beginning of the session, whereby we were asking about the topics of bridging tables, etc., and overcoming potentially some of the, like you say, from your experience, some of the DAX solutions that have been put into place that could have been solved just by the data model as such.
I think that's a fantastic idea. So yeah, like you said, this was 101. We can schedule a time to do a 201, and it will be much more hands-on. So yeah, I can be in contact with you or go through Pragati, who was gracious enough to introduce us, and we can absolutely do that in the future.
Definitely. That sounds absolutely fantastic. Well, what I'd like to do, Ed, is first and foremost, thank you very much for taking the time out of your, I know your busy schedule, and joining us at the Microsoft Power BI UK user group for today's session on data modeling. Like I say, I think it's been a wonderful wealth of information that we've fitted into this time, and I can see by the comments that our users have really benefited from your knowledge on the subject. So thank you very much for putting together the time for us.
No, very happy to do it. Very, very honored to be here. And I will be in touch with you after this via email. I'll make sure you have a copy of the deck and even my PBIX file if people want to play with it.
Fantastic. Well, thank you very much. And thank you to everybody that's joined us this evening or morning or afternoon, depending on where you are. You could have been anywhere in the world, but you've been here with the Microsoft Power BI UK user group for today's webinar sponsored by Onyx Data. Thanks again. See you all soon. Stay safe.
Okay. Bye-bye.